I'm Alex, a cloud support engineer here at the AWS office in Sydney. Today, I'm going to show you how to identify when your Amazon Elastic Block Store volume is microbursting and prevent it from affecting performance. Let's get started. Microbursting occurs when your Amazon EBS volume experiences short bursts of high IOPS or throughput that Cloudatch metrics doesn't capture because the metrics collect samples at 1-minute intervals. To identify microbursting, first check the volume idle time metric. After you sign in the AWS Management Console, navigate to the Cloudatch console. Choose Metrics, and then choose All Metrics. Select EBS, and then choose Per Volume Metrics. Finally, select the Volume Idle Time metric. When the volume idle time metric is high, the volume is mostly idle. So, if there's high IOPS or throughput during this period, then the EBS volume might experience microbursting. Next, use these formulas to calculate the estimated average throughput and IOPS. The formula of estimated average throughput is to calculate a volume's throughput using volume read bytes and volume write bytes metrics, and dividing by its affected period using volume idle time metric. And the formula of estimated average IOPS is to calculate a volume's IOPS using volume read ops and volume write ops metrics, and dividing by its effective period using volume idle time metric again. Both formulas consider the period when the volume was actively in use in the equation. To view microbursting in Cloudatch, open the Cloudatch console and clear any graphed metrics. Choose the Browse tab, search for the volume ID, select the volume read bytes, volume write bytes, volume idle time metrics. Choose graphed metrics, and then use the sum and the 1-minute period to adjust the metrics. Add the formula for estimated average throughput, starting with an empty expression. Now, each graphed metric has an ID in Cloudatch that links to the math expression. Make sure that M1 and M2 refer to volume read bytes and volume write bytes, and M3 refers to volume idle time. Deselect M1, M2, and M3 and keep only E1 selected. You can also rename the label to Estimated Average Throughput. If the graph exceeds the volume's max throughput, then microbursting occurred. To check for IOPS microbursting, repeat the steps with the volume read ops and volume write ops metrics. You can also use operating system level tools such as IOStat on Linux or perfmon on Windows to get more granular I/O statistics and confirm microbursting. On Linux, run the following command to report I/O statistics with 1-second granularity. To determine if microbursting occurred, review read megabytes per second and write megabytes per second in the output. If their sum is greater than the volume's max throughput, then microbursting occurred. For IOPS microbursting, review read per second and write per second in the output. If their sum is greater than the volume's max IOPS, then microbursting occurred. To prevent microbursting from affecting performance, depending on the volume characteristics, either modify its settings or modify to a different type or size that can accommodate your peak IOPS and throughput requirements, even during bursts. For example, A GP3 volume type allows modification to IOPS and throughput values. Navigate to EC2, choose Volumes, select the Vault ID to modify, choose Actions, modify volume. Modify IOPS and throughput to accommodate your requirements. Choose Modify and confirm the modification in the pop-up window. Make sure to check out the Knowledge Center article when performing a volume modification, and it's best to benchmark volumes against your workloads in a test environment first. So now you know how to identify when your Amazon EBS volume is microbursting and prevent it from affecting performance. Thanks for watching, and happy cloud computing from all of us here at AWS.